In this video, we will be going over the trigonometry of right triangles. This includes solving right triangles and evaluating trigonometric expressions. In this problem, we've been asked to define all 6 trigonometric functions for the given right triangle. Given that we know the phrase SOHCAHTOA, we can identify what each of these trigonometric functions stand for. Given that we know sine is opposite over hypotenuse, cosine will be adjacent over hypotenuse, and finally tangent will be opposite over adjacent. Once we have that phrase, we can begin solving for these angles. First, we need to find sine of theta. We know that sine is opposite over hypotenuse, so we can say x over z. For the cosine of theta, we know that cosine is equal to adjacent over hypotenuse, so we can say y over z. And finally, we know tangent is equal to opposite over adjacent, and so we can say the tangent of theta is equal to x over y. With the previous knowledge that cosecant is equal to 1 over sine, we can say the cosecant of theta will be equal to z over x. Given that we know that the secant of theta is equal to 1 over the cosine of theta, we can say secant of theta is equal to z over y. And finally, we know that cotangent of theta is equal to 1 over the tangent of theta, and so we can say cotangent of theta is equal to y over x. Given that we have now defined the previous 6 trigonometric functions, we can now solve the following right triangles. For our first triangle, we are given an initial angle of theta being equal to 40 degrees, so we can label that in the triangle. And we are also told that y, the adjacent side to our theta, is equivalent to 13. A calculator will be necessary to find some of these solutions. Ensure that your calculator is in degree mode by first saying mode and setting this to degrees. The first thing we want to determine is the other angle in this triangle, alpha. We know that a right triangle's angles must add up to 180 degrees, and that this angle here already takes care of 90 degrees. And so we take the remaining 90 degrees and subtract from it 40 degrees for theta, and we find that our alpha has an angle of 50 degrees. Next, we wish to solve for z, the hypotenuse of our triangle. We know that the cosine of theta will be equal to y over z, or adjacent over hypotenuse. And so we can say the cosine of 40 degrees is equal to 13 over z. We can then solve for z by saying 13 divided by the cosine of 40 degrees, and we find that z, our hypotenuse, is equal to 16.97 or 17.0 when rounded. The next side we wish to find is x. There are a number of ways we can do this, but for this problem we will use the trigonometric function. Sine of theta is equal to x over z, and so we can say sine of 40 degrees is going to be equal to x, the value we're looking for, over z, which we just found as 16.97. And so we can plug this into our calculator as 16.97, or our previous answer, times the sine of 40 degrees. And we find that the x side for our triangle is equal to 10.9. We can now fill in these values on our worksheet. We found that our angle alpha was equal to 50 degrees. We found that our side x had a length of 10.9. And we found that our side z had a length of 17.0. For our next problem, we do the same thing once again, the only difference being that now we are given an angle of alpha, and this angle is in radians instead of degrees. Please ensure that for all of these problems, your calculator is in the appropriate mode to find the solutions. We can now fill in the values that we are given. We are told that alpha has an angle of pi over 4. and we are also told that z, our hypotenuse, has a length of 17. We can first solve for our angle theta by noting that the triangle must have a total angle of 180 degrees. The right angle here already accounts for 90 degrees, or pi over 2. So if we take our total triangle angle of pi, we subtract the right angle of pi over 2, and we also subtract the given angle alpha of pi over 4. We can then find our theta. Doing the math on this, you'll find that your theta is going to be equal to pi over 4. Next, we can solve for our side length y by noting that the sine of alpha will always be equal to opposite over hypotenuse, and in the case of the angle alpha, our opposite will be y over the hypotenuse z, which was given as 17. We can then solve this in our calculator by taking the sine of pi divided by 4 multiplied by 17, and we find that our side length y is going to be equal to 12.0. We can also solve for our side length x by saying the sine of theta is going to be equal to x over 17. This is because for theta, the opposite side will be our x, and our hypotenuse is still z, or 17. We know that theta is equal to pi over 4 from our previous solution, and so we would be plugging the same thing into our calculator. The sine of pi divided by 4 multiplied by 17, and we once again get 12.0. And so we can plug in the values that we determined. Our angle of theta is pi over 4. Our side length of x was 12.0 when rounded, and our side length of y was also 12.0 when rounded. For our last problem, we are asked to evaluate the following trigonometric expressions. For the first one, we have sine of pi over 3 multiplied by the cosine of pi over 6 plus the cosine of pi over 3 squared. For the sine of pi over 3, we know from our unit circle this will be equal to the square root of 3 over 2. Additionally, from our unit circle, we know that the cosine of pi over 6 is also equal to the square root of 3 over 2. And finally, from our unit circle, we know that the cosine of pi over 3 will be equal to 1/2, and this value needs to be squared. For the left side of our expression, we can say the square root of 3 times the square root of 3 will just give us a value of 3 over 2 times 2, 4, plus 1/2 squared. 1 squared will give us a value of 1 over 2 squared, giving us a value of 4. And so the solution to our first expression is 3/4 plus 1/4, or simply 4 over 4, which is equivalent to 1. For our next expression, we wish to evaluate the tangent of 45 degrees multiplied by the cosine of 30 degrees times the sine of 45 degrees minus the sine of 30 degrees times the cosine of 45 degrees. For the first part of this expression, the tangent of 45 degrees, if we remember from our unit circle, the x and y coordinate were both the same. And so the tangent, which is equal to the y-coordinate over the x-coordinate, will be 1. And so the tangent of 45 degrees is 1 multiplied by the cosine of 30 degrees, which if we remember from our unit circle was square root of 3 over 2, this being the same as the cosine of pi over 6, multiplied by the sine of 45 degrees, which our unit circle was the square root of 2 over 2. And from this, we subtract the sine of 30 degrees, which will be 1/2, multiplied by the cosine of 45 degrees, which is once again the square root of 2 over 2. On the left-hand side of our equation, we have square root of 3 times square root of 2 times 1. This is the same thing as just square root of 3 times the square root of 2, which is the square root of 6, divided by 2 times 2, which is 4. From that, we subtract 1 times the square root of 2, or just square root of 2, divided by 2 times 2, which is again 4. This will be equivalent to square root of 6 minus the square root of 2 divided by 4. This concludes the video on trigonometry of right triangles, including solving right triangles and evaluating trigonometric expressions.